Hello and welcome to Selenium for Beginners. We are going to discuss the relationship between HTML, web elements, and the document object model, better known as DOM. The transcript and presentation will be available on GitHub at rexjones2 /Selenium for Beginners and tinyurl.com Selenium Locators for web elements. The complete lesson plan will include the relationship between HTML, web elements, and the DOM. Then I will show you how we use Selenium Locators to find web elements. There are 8 Selenium locators. One of the locator types for Selenium is XPath, and another locator type is CSS selectors. I'm going to demo how to create our own customized XPath and CSS selector values. Let's start with HTML by using W3 schools. We are going to focus on 3 topics: HTML introduction, HTML elements, and HTML attributes. HTML stands for Hypertext Markup Language. It is a language designed to create web pages. Let's try it. We see HTML on the left and the results on the right. The first HTML line shows an exclamation point, doc type in all capital letters. Doc type is a declaration representing an HTML document type to help all browsers display web pages. HTML documents have elements defined by tags. In this example, the tags are HTML, head, title, body, H1, and P. HTML is the root element, and head is an element that contains metadata. That's why we see title as one of the elements within the head element, because title describes the document title. After the head element is body, which contains the prime content of the page. H1 means header, and P means paragraph. H1 is the biggest header. The header becomes smaller when the number increases. For example, I'm going to write H2, my second heading, then click run. The words are smaller in the results pane. That's a quick introduction of HTML. Now, let's look at HTML elements. An element consists of a start and end tag with content inserted between both tags. Here's the syntax for an HTML element. Do you see the difference between a start tag and end tag? An end tag contains a / before the tag name. There are times when we will come across some empty elements, which are elements without an end tag like BR. BR is a line break, meaning it will skip a line. HTML attributes provide additional information about HTML elements. Most of the times they come in name value pairs. The href attribute is defined with the A tag. A stands for anchor, and href is an acronym for hypertext reference. This A tag and href attribute are used to create links. We see href has a value of www.w3schools. W3 Schools web page will show up after clicking this link. We see href and src attributes, but the key attributes for finding web elements are class, ID, and name. Class and ID are global attributes. Global attributes means an attribute can be used by any HTML element. We see class specifies one or more class names for an element, and ID specifies a unique ID for an element. Name is not a global attribute, but it can be used on many HTML elements, and it specifies the name of the element. Other attributes can be used to find web elements, but ID, name, and class are the main attributes to find web elements. What is a web element? A web element is an element from HTML displayed on a web page. It can be a hyperlink, image, button. Anything you see on a web page is considered a web element. Sometimes we say elements for short, although there is a difference between element and web element. A question someone may ask is, how are web elements displayed on the web page? They are displayed on a web page when a browser such as Chrome reads the HTML document, then renders the document. Rendering a document means taking the HTML content and converting that content to what we see on the web page. However, there is an interface for managing the web page, and that interface is called the Document Object Model, DOM. The DOM is an API, application programming interface, that handles HTML documents as a tree structure by identifying three things. Number one, it identifies how to access an HTML document. Number two, it identifies how to manipulate an HTML document. Number three, it identifies the logical format of an HTML document. Here's the tree structure of a DOM using the HTML from W3 Schools. At the top, we see documents, then an HTML root element. Under the root element, there are two elements, head and body. Head has title as an element, while body have header 1 and paragraph as elements. We can right-click on any browser and inspect elements using developer tools. Inside the Elements panel, Chrome has a DOM structure, which includes all elements of the current web page. This DOM structure defines the page structure. We can click Ctrl F to find an element from the DOM by string, selector, or XPath using this locator. Next, we are going to use Selenium Locators to find web elements. Before checking out how to use a Selenium Locator to find a web element, let's look at the Selenium Locators. Then at the end, we are going to look at the rankings for the Selenium Locators. In alphabetical order, the 8 Selenium Locators are class name, CSS selector, ID, link text, name, partial link text, tag name, and XPath. Now, let's look at the Selenium Locators that help us find web elements. I believe finding a web element is one of the most important aspects of automation. Why? Because we are unable to perform any action on a web element until we first find the web element. I have already created an instance of web driver, a setup method to load orange HRM, and our test method, demo Selenium Locators. Recall from the previous video, I mentioned ID, name, and class are the key attributes for finding web elements. Therefore, I will start with ID, which is a unique identifier for finding an element. We write driver.findElement by then the dot operator. Here's a list of all 8 Selenium Locators. Select ID, and the parameter is the value of ID attribute. Let's go to the AUT and find the value of ID by inspecting user name. The value is txt username. Copy the value and paste the value. Web element username. We are not going to perform any actions on the web element, but only find the web element. As a result, I will demonstrate finding the web element by highlighting each web element. Highlighter dot highlight element. Pass in the driver and username as the element. This is a static highlighter method. Therefore, I can call it directly from the utility package. The background will be red and the border will be black. Highlighter methods are good for demos because it can slow down execution. This execution will slow down for 1 second due to thread.sleep 1000. Let's run. Did you see username highlights red? That shows we successfully found username. We are going to do that for each web element. Driver.findElement by name. And the parameter is the value of name attribute. Inspect password, and the value is txt password. Copy, paste the value. Web element password. Highlighter dot highlight element, pass in driver and password as the element. Let's run again. Then we see username and password highlight red. Driver dot find element by class name. And the description states, find elements based on the value of the class attribute. Inspect button. The class attribute has a value of button. Copy and paste the value. Web element button login. Highlight element passing driver and button login. Let's run. We saw all three web elements show a red background. The next two Selenium locators help find links on the web page, link text and partial link text. Driver dot find element by link text, and the parameter is the exact text to match against. Driver dot find element by partial link text. Let's use forgot your password for link text and orange HRM for partial link text. Inspect both elements, and here's the text for forgot your password and orange HRM text. Paste forgot your password, web element, link forgot password. Highlighter dot highlight element, pass in driver, pass in link forgot password. The value for partial link text will be orange HRM. Web element link orange HRM. Highlighter dot highlight element, pass in driver and link orange HRM. We have to scroll down the page before partial link text, so let's add a comment to scroll down the page. The next Selenium locator is tag name. We are going to find all of the tag names for an image. I'm going to move Chrome Dev Tools. The locator Control F can help us see how many tags have IMG. 2 forward slashes, IMG. There are 5 tags with IMG. Let's look at the 5 images. The first image is at the top, and the next 4 images are at the bottom: LinkedIn, Facebook, Twitter, and YouTube. Go back to Eclipse, and this time we type driver dot find elements with an S, because we are looking for more than one web element. The description shows find all elements within the current page. Notice the syntax for assigning all web elements is list, angle brackets with web element in between the brackets. We continue with by dot tag name, double quotes, IMG, list, then the angle brackets, web element, images, import list. This time we loop through all of the images by writing for web element image. Images is a list of all images. On the other hand, image is a temporary variable. Therefore, we write highlighter dot highlight element, pass in driver, and element is image. Now, let's run. Everything highlighted red, all of the web elements. Let's look at the rankings for Selenium Locators. ID is number 1 because it's a unique identifier for an element. Number 2 is name. Most of the times, name is unique for the web page. I have seen cases where ID and name are unique for an element, but not unique for a page. If an ID or name attribute is not available, then third is class name. A class name does not have to be unique. There can be one or more class names for an element. Some elements may not have a class name at all. Link text and partial link text are good, but can lead to flaky values because text on a page can change. Here's an example of the language changing from English to Spanish. I showed you tag names, but they are not effective if you are looking for one element because it returns all elements. Therefore, if text can change on a page, and it's also possible for ID, name, or class to not be available, what should we use? We should use any one of the most powerful Selenium locators, XPath or CSS selector. Next, we will look at the XPath Selenium locator. Hello and welcome to Selenium for Beginners. We are going to discuss how to create our own customized XPath values. The cheat sheet, transcript, and presentation will be available on GitHub at rexjones2/Selenium for Beginners and tinyurl.com/Selenium Locators for web elements. We will look at the difference between absolute and relative XPath values, XPath functions, and XPath axes. We are going to use 4 different applications to walk through all of these XPath scenarios. What is XPath? XPath is used to navigate through elements and attributes. XPath is short for XML path, and XML stands for Extensible Markup Language. XML is different from HTML. XML is used to carry data, and HTML is used to display data. With regards to Selenium, XPath is a locator used to extract or pull tag attributes. There are 2 types of XPath, absolute and relative. Here's the syntax for an absolute XPath. The absolute XPath always begins with the root element which is HTML. It can start with a forward slash before HTML or without a forward slash before HTML. However, a forward slash will always come after HTML, followed by head or body as the next element, and stop with the last element. Relative XPath always starts with 2 forward slashes, which selects a direct tag name, followed by a condition. The condition is located inside 2 square brackets using an @ symbol, attribute equal to the value, surrounded by single quotes. Our first application is Demo Web Shop. Let's inspect the search button. As automation engineers, we should not copy the XPath values from Chrome Dev Tools. That's when we right-click, select Copy, Copy XPath. Control F, then paste the value, and we see an absolute XPath value. Sometimes Chrome DevTools generates a relative XPath value. I will admit, I have used Chrome DevTools to copy XPath, but that's because I had not created a video showing how to customize our own XPath values. Let's break down this absolute XPath. It starts with /HTML. Then we see body. A / provides access to the next element, which is a child element. Within body, we see 4 div tags. 1, 2, 3, 4. The XPath shows div 4, which means the 4th div tag. Maximize div 4, and we see 2 div tags. The XPath shows div 1. Maximize div 1. Now we see 4 div tags. The XPath shows div 1 again, and we see 4 more div tags. But this time we need the 3rd div tag because XPath shows div 3. Maximize div 3, and we see the form tag. And finally, the input tag. And XPath shows input 2, 1, 2. And we see all of the attributes for the search button. That's a lot of navigation to find one element. It's not a good practice to write an absolute XPath. If anything changed between HTML and input 2, such as div 1 changing to div 2, then Selenium will no longer find the search button. That's one of the reasons why we should not use absolute XPath. I recommend we use relative XPath. Here's the cheat sheet for relative XPath. I created it as a reference for you to download. First syntax for the search button, we write 2 / and the tag name input. There are 15 web elements with inputs as their tag name. We can write any tag name and see how many elements contain that tag name. The search button is 2 of 15 for input tag. Continue with an opening and closing square bracket. @ symbol, then attribute name. The attribute's name can be any attributes within this element. Type, class, or value. Let's write type. Followed by an equal sign. After the equal sign, then write 2 single quotes, and the attribute value submit. We see the element shows a green highlighted background, which means success. If we hover over the element, then the web element is highlighted in the application. That's the difference between absolute and relative XPath.
Selenium for Beginners with Rex Jones II.
The next syntax is an illustration of two or more attributes, names, and values. This syntax operates like the logical AND operator using two or more conditions. Let's inspect the Excellent Radio button. According to the Selenium Locator rankings, we would use ID or name before using XPath. However, here's the power of XPath. Let's imagine the application is under construction and the architect wants to make sure these attribute values do not change. We find the element by using multiple attributes, and if it breaks, we know one or both values change. 2/, tag name input, square brackets, @ attribute name ID, equal, 2 single quotes, then the attribute value polled answers -1. We found the element, but let's add the square brackets again, @name equal, 2 single quotes, then polled answers -1. Success. The next syntax is the AND operator. It's our preference. We can use the AND operator or multiple sets of brackets. Go back to the AUT. All we do is replace the inside brackets with AND. We still have our element with 1 of 1. Both syntaxes operate the same. The next syntax is the OR operator. Change AND to OR. But now we have 1 of 4. Search, search, search. Why is that? That's because all 4 radio buttons have the same value for name. Poll answers -1. Let's inspect search store. This is a different scenario. Imagine the architect is okay with one of the attribute values changing, but we still want to find this element. We replace ID with small hyphen search terms and the name with Q. Now we see 1 of 1. There are times when we have to use indexes to find our element. The next syntax has an index for tag name. We are going to switch AUTs and look at tables using W3 schools. Inspect Helen Bennett. It's best to write this XPath by starting with an attribute within the table tag. Table is the parent element for tBody, taura, and td. tBody describes the table body. Taura is table row, and TD is data in a particular cell. 2 forward slashes, tag name table, square brackets, at attributes name ID equal 2 single quotes. Then the attribute's value is customers. 1 forward slash after the bracket, which provides access to the child element T body. Which row is Helen Bennett? 1, 2, 3, 4, 5. We write forward slash TR bracket 5. Helen Bennett is the second cell, 1, 2. Therefore, we write forward slash after the bracket TD brackets 2. The green background indicates we have found Helen Bennett. You can find this cheat sheet at tinyurl.com, Selenium Locators for web elements, and GitHub at Rex Jones II / Selenium for beginners. Next is XPath functions. The next AUT is GitHub. Let's inspect the notes below username. Here is a special case where XPath or CSS selector is our only option, and a perfect example to show you why we should not use Chrome Dev Tools to copy XPath. Copying an XPath value works sometimes, but it is not reliable. Therefore, it is best not to right-click, copy XPath, then paste XPath. Notice the ID value. Now I am going to reload the page. Copy XPath again, then paste XPath. Do you see how the value changed after reloading the page? That is called a dynamic ID value, where the value changes every time. This video will show you how to handle dynamic values using XPath functions. There are 4 types of XPath functions. On Oracle sites, we see node set, string, boolean, and a number. Our focus will be the string function. In our cheat sheet, I call them partial pattern match, because all we need to do is match parts of the attribute's value. I was going to demo 3 functions, but I will remove ends with, then demo starts with and contains. Back to our AUT for the starts with function. We write 2 forward slashes. Tag name is P. Opening and closing brackets, starts with. Opening and closing parentheses. At symbol, the attribute name is ID, comma, 2 single quotes. Then write what the value starts with. The value starts with description. So let's write description. We can also replace starts with and use the next function contains. Both functions will work because the value starts with description and also contains description. Go back to AUT, remove starts with, then add contains. Did you notice that we have found 1 of 2? 1 of 2 is not good enough if we are looking to only verify the notes below username. Both elements almost look the same. How do we find one of one when both elements have P as the tag name, class attribute with the value of note, and a dynamic ID value? One note refers to the username and the other note refers to email address. We can use a word or we can use a phrase from the note. Inside the brackets, we write and contains. 2 parentheses, we write dot, comma. 2 single quotes. Within the quotes, we can write the complete phrase or we can write the word. The phrase can be, "This will be your username." Now we have one of one. However, I prefer to use a unique word like username. And we still have one of one. This query is asking us to find a P tag and ID attribute consisting of a description value and contains text username. We can also replace the dot with the text function. However, there are cases where text will not work. I will create a video explaining the difference between using an XPath value using a dot and using text. TEXT, 2 parentheses. We still see one of one. If you choose not to write the word and, you can replace it with the square brackets. Let's go to Tools QA and continue with a different syntax for the text function. Inspect first name. We see a strong tag name but don't see any attributes. Write 2 forward slashes, strong, both brackets, text, 2 parentheses, equal, 2 single quotes, first name, colon, and bingo, we found our element. That's it for XPath functions. Next is XPath axes. Next is XPath axes. An axis represents a relationship. That relationship depends on the current node, and it is used to find other nodes like a parent node, sibling node, or child node. There's a total of 13 XPath axes. In alphabetical order, the XPath axes are: number 1, ancestor; number 2, ancestor or self; number 3, attribute; number 4, child; number 5, descendant; number 6, descendant or self; number 7, following; number 8, following sibling; number 9, namespace; number 10, parent; number 11, preceding; number 12, preceding sibling; and number 13, self. Here is the syntax for an XPath axis. Axis specifies the tree relationship between current node and selected nodes. The 2 colons separate an axis and node. The node identifies the tag name, and index is not required. It specifies the node sequence. We are going to cover the following and preceding XPath axes. The preceding axis select all tag names before the current node, and following selects all the tag names after the current node. Let's pick up where we left off after using XPath functions. Right now, we have already found the first name label. To use the preceding XPath axes, we write 2 forward slashes. Next is the preceding axis, 2 colons, then the tag name. The tag name depends on the elements we are looking for. How about the link element, which has an A for anchor as the tag? This query returned 177. The index is optional, but let's narrow our search down to link text by writing 1. 1 represents the first anchor that precedes the first name label. To select partial link text, we write 2 because it is 2 elements before the first name label. The next axis is following. Let's select all of the input tags after years of experience. Inspect years of experience. We see a label tag name. Let's write 2 forward slashes, label, brackets, @ symbol. There are 2 attributes, class and for. If we use class equal control label, then the query returns 3 elements. 1, 2, 3. Years of experience, profession, profile picture. Therefore, let's use the for attribute. FOR, EXP. Now we see 1 of 1 for years of experience. Then write 2 forward slashes, following, 2 colons, input. There are 20 input elements following years of experience. Search, 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 search. Some of the elements are the radio buttons for years of experience, date picker, manual tester, automation tester. That's how we select web elements using XPath axes. Next is creating our own customized CSS selector values for Selenium. Hello and welcome to Selenium for Beginners. We are going to discuss how to create our own customized CSS selector values. Let's start with the hashtag, which represents the ID attribute, and the dot, which represents the class attribute. We are going to use orange HRM as our AUT, application under test. Inspect username. And we see an ID attribute. To find this element using ID, we write the tag name input. And we see 22 elements with an input tag. Hashtag, then paste the value for ID, which is search system user underscore username. The green highlighted element means we successfully found username. Next is the class attribute. Let's inspect the search button. And we see class has a value of search button. Write input dot search button. The element is highlighted green. Did you notice the Chrome Dev Tools provide a CSS selector value over the web element? Hover over the search button and we see input hashtag search capital BTN dot search button. It combines the ID and class attributes. Input hashtag search capital BTN dot search button, and we have our element. However, only one attribute is sufficient if it contains a unique value. We can also find an element using ID or class without writing a tag name like hashtag search capital BTN, but it is best to include the tag name. The next two syntaxes show tag name and a condition. Attribute name equals attribute value. We have the option of adding more than one condition. Both of these syntaxes look like an XPath syntax. The difference is XPath has 2 forward slashes and an @ symbol. Let's inspect the delete button and write a query. We see our element. Write tag name input, 2 brackets, then write type. And we see 18 elements. Narrow the search for type by writing equal, 2 single quotes, and submit. Now we see 1 of 1. If we change submit to button, then we see 8 elements, which include search, reset, and add. The developer has delete as a different type than the other buttons. Next, inspect image. There are 4 attributes: src, width, height, and alt. Let's pretend a requirement wanted to make sure the width and height is a certain size. We can write img for tag, 2 brackets, width equal 2 single quotes, and 283 for the first condition. The second condition, 2 brackets, height equal 2 single quotes, and 56. Bingo, we have our element. Next, we're going to look at some advanced CSS selectors. Next, we are going to look at some advanced CSS selector values. Let's walk through the int-child syntax, parent-child relationship syntax, and 2 matching patterns. The int-child syntax is a pseudo-class used for indexing. A pseudo-class is a keyword preceded by a colon and added to the end of a CSS selector. The parent-child relationship is all about a direct relationship between elements. We match part of a pattern using a symbol and some of the attribute's value. Pattern matching is good for dynamic values. Our first example will combine the int-child and the parent-child relationship. I'm going to reload the page because I added some more values in this table. We're going to inspect Linda Anderson. Just like with our XPath example, we're going to start with the table tag name. Table has 2 children, T-head and T-body. T-head forms the header, and T-body forms the body, containing all of the rows and data. TR defines each row, and TD defines data in each cell. we write the tag name table, 2 brackets, attribute name ID equal 2 single quotes, attributes value result table with a capital T. Now we need T body, which has a direct relationship with table. Table is the parent. Therefore, we write angle bracket T body. Next is the row, and Linda Anderson is on 1, 2, 3, 4th row. A child of T body is T aura, so we write another angle bracket, then T aura. Here is the pseudo class nth child. We write colon nth hyphen child parenthesis 4. Finally, we have the data. Which cell is Linda Anderson? Let's count. The checkbox is considered data in a cell. 1, 2, 3, 4. Last, we write another pseudo class for nth child. Angle bracket TD colon NTH hyphen child parenthesis 4. There it is, Linda Anderson. Know what? You can go to W3 Schools for a reference. W3 Schools, CSS selectors. .class selector. Now let's look at the CSS selectors. Here's a list of many CSS selectors. Our next AUT will be yahoo.com. Let's inspect this sponsored element. We see the U tag has an ID attribute. However, the value for ID is dynamic. It will change after reloading the page. Right now, it ends with 1364. Reload. Inspect again. And now it ends with 985. Therefore, copying the selected value will not work and cause our test script to fail the next time it executes. There are many elements on this page with a dynamic value. How do we find dynamic values using a CSS selector? Our cheat sheet shows some of the symbols for matching a pattern. Starts with every element with a particular substring. Go back to our AUT. We can write the value it starts with. Tag name U, 2 brackets, ID, caret symbol, equal, 2 single quotes, YUI. There it is. We can also match a substring of the attribute's value, which is sum of the characters. Replace the caret with an asterisk, and we still have our element. That's it for CSS selectors and this series that includes the relationship between HTML, web elements, and DOM. Using 6 of the 8 Selenium locators to find the web elements, create our own customized XPath values, and create our own customized CSS selector values. The cheat sheet and the transcript will be available at tinyurl.com Selenium Locators for web elements, and GitHub at Rex Jones II /Selenium for beginners.
Online courses coming soon. Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.